check. Okay, I can hear myself through a mic, so that sounds pretty good. Are you all good back there with this mic? Is it turned? Okay, lovely. Well, hi. Welcome to October. Welcome to October ITS Georgia meeting. Really glad to have you. Thank you to Applied Information having us up here at this wonderful facility. Before I go any further, if there's anybody that has not eaten, I think there's a few walk-ups. There is food that you can grab, so please go grab it. But in the meantime, again, thank you all very much for coming. I'm really excited to be having Brian come up here in a few moments to tell us about what's new at Applied Information. And again, thank you to them as our sponsor for the month. We really cannot do it without our sponsors. So it helps us keep our prices where they are. So thank you to that. A few announcements before we get going. First up is Southeast Summit. So I know we're coming right out of ITS World Congress, but we have ITS Southeast Summit, which is going to be much better than ITS World Congress. There are a bunch of nerds there. For those of you that are not aware, it'll be in Charlotte from March 22nd through March 26th. Would love to have you there. This has been something that we've been doing with the other chapters for at least 10 years now. I think this is what, our third or fourth venture into this, Yancey. You know better than me. Nodding your head. Third, okay. Third? Fourth, okay. But there, you know, again, if you have not been, it is Georgia, Florida, Alabama, Mississippi, Louisiana, South Carolina, North Carolina, Tennessee, and then, you know, if Kentucky and West Virginia and Virginia want to come, they can. But it's honestly, for those of you that are on the consulting side, it's awesome because everything is crammed into one. All the chapters commit to this being their annual meeting. So from a budgeting standpoint, it makes everything a lot easier for the consultants and the vendors and the contractors. And there's usually, I think, something like 250, 300, 400 folks just from all the different DOTs that come. So with that as well is the call for abstracts remains open. They've done it a little bit differently than they normally do it. So if you are, the way they've done it this year is a bit like an RFP. So if you're a consultant, if you're a contractor, or if you're a vendor, and there is a passion project, passion idea that your company wants to showcase off, right? It's not necessarily about Arcadis or Kimley Horn or AECom, but it's about cloud-based TSP, right? If that is something that you think is super cool and you want to get together a session, you can respond to that RFP. You as a firm would be the sponsor, so you get to get up just like Brian's getting ready to do and talk about your firm and all that great stuff. So again, a little bit different, but that is open until October 31st. Very much encourage you to do it. I know there are a few firms in here that have already, so thank you. And a few firms that haven't already. Mark Start, you should put one in for AECom. Calling you out. I tease. With that as well, there are also the regular good old-fashioned sponsorships that are open. Again, if you are interested in doing that, very much encourage your firm to take part in that. You will note that registration should have been open. It is not quite open yet, so don't panic. But I would say go ahead and mark your calendars for March 22nd through the 26th for Charlotte. Next up, training. So we have two meetings coming up, one of which is our training. We are tentatively targeting mid-December for that. And what we are thinking is a little bit different than normal, what we've done in previous years, is that rather than one very focused training on insert topic, is the idea is to engage our state, local partners who have had changes to their standards or perhaps differ from state, you know, if you're a local agency, how your standards differ from GDOT's. But at 15, 30, 20-minute sessions, basically for you to make sure that the consultant community, the contractor community, as well as just your peers, know the differences and what's changed for your agency. So that's going to be the topic that we're thinking about for December. And then for November is our awards banquet and an announcement of our new board. That will be, Tom, November 18th. Is that right? Yes. Yes, November 18th at Maggiano's, Cumberland. Love to see you guys there. Register early. That usually sells out. I think we do cap it at 100, which is great, but it usually sells out. So please join us. Love to have you. Great food. Again, you'll just have to listen to me talk for like an hour, so that's, I don't know if it's worth it. With that, Brian, I think I'm going to hand it over to you now at this point to do your piece.
Yeah, appreciate it. Thanks. All right, just double check that everybody can hear me okay. First of all, welcome everybody. This is like having guests in our home. So love having you guys all here. And I'm Brian Mulligan. I'm the CEO of Applied Information. And we're the builders of this Glance platform. You'll see a bunch of people running around with Glance shirts on. And what that does is, have I got a clicker? I've got a clicker. There. All right. What drives us is, for the techno geeks in the room, this is what I call the Glance equation. And we try to do the maximum good for the maximum number of people in the minimum amount of time. That's what drives us. That's why we get up every day and build this team of people who focused on applications. So everything we do is focused on applications to actually make the traffic work better. Save lives, improve traffic, drive commerce, healthy environment. We've split Glance into 6 divisions. And so there are a bunch of folks here in this lab and so forth. They're all wearing Glance shirts who can help you about any one of these things. Alana, our VP of Sales, can talk about school beacons and pedestrian safety, what we do about all of that. Dominic leads our fire and EMS division. Dominic, somewhere in the back there, wearing the fire, what I call the fire uniform. It's no hair and a mustache. Our Glance traffic is led by Kerry Lord. Kerry's just joined us, and Kerry's somebody about the thing. I think all of you know Kerry, so welcome Kerry. Have a chat with him about why he joined us. Remote communications and video. Connected vehicles, you guys know Peter Ashley. All the stuff that you see in the lab has a story about it, and whatever interests you, just go and have a look. And then Bob Reeby's our VP of Transit. He's on travel. And then also I'd like to give a shout out to Alex Teams, who's just standing up our GIS division, because we're have got a lot of data. This is the map of where we deployed what we call the Glance connected infrastructure. 55,000 devices, all talking to us in 1,650 cities, counties, and states. So we got a lot of real-world experience out there. We write 8 million records a day into our database, and that's what's telling us the story about, are we helping fire departments get to paramedics in need? Where are the underserved areas of your city? Are school beacons slowing the traffic down? Are the school buses working? Are the transit buses keeping schedules and actually delivering the right service to their customers? So this is what the Glance connected infrastructure is. And there's a story about each one of these 1,650 cities, and anywhere where you're from or wherever. Oh, no, what have you got there? Somebody will drill down and have a look at what we do there. That leads us to the iATL where you are. So the Infrastructure Automotive Technology Laboratory, we stood up 5 years ago. And obviously 5 years ago, the first thing that happened to us is COVID happened to us. And so this is what this space was for, is to have meetings like this. Because what we say is competition stops at the door. These are all the folks who've joined the iATL Partner Alliance, and we encourage you to join them. It's a non-binding agreement to agree that what we do is we all work together to deliver better connected transportation. And so these are all the folks who've joined up, who come here and test here. There's every kind of traffic controller in use in North America in this lab here, all the different radios, all of that. And so this is what makes it all work, is when you collaborate and it all works together. A couple of pictures. We had the world here for the 5GA. They brought everybody to Atlanta. They all came here and saw all these applications working in the street. I think we were one of the official tours, and then we ran a further 16 private tours when ITS World Congress was here. And we had lots of people coming and experiencing the iATL, which is not only what happens inside this, this lab, but it's also the, when it whistles a bit if I stand in front of the mic. But also 75 square miles of Alpharetta equipped with radios, equipped with technology, and you can see it all working here. And so what I encourage those who are interested, Siobhan over here has got a sign-up sheet for drives. People who want to experience these applications will do drives in autonomous Teslas, and you can experience how all of that works. You can see it all working. If there's anything that's particularly of interest to you, like you'll see there's a street light on there. Well, what is pedestrian activated lighting, and how does that make the world a safer place, and so forth? Anything that catches your eye, there's an expert there ready to explain it to you, and what we do, and how we're delivering value out there in the market. So with that, thanks for coming, and enjoy your time with us, and make sure to talk to people afterwards. The place is open for your convenience, and join the iATL and go for a drive. Thanks very much.
Thank you again. Applied Information having us here. It's a wonderful facility. Thank you for handling the food for us. It's been very delicious. But with that, Ashlyn, I'm going to invite you up to introduce our speaker for this afternoon.
All right, thanks, Matt. Hey, everybody. I'm Ashlyn Morgan, as Matt said, and I have the pleasure of introducing our speaker for today. Victoria is the V2X Program Manager for the Georgia Department of Transportation, which is home to one of the nation's most extensive connected vehicle programs. She oversees the operations and maintenance and strategic expansion of the V2X equipment applications throughout. Victoria is a graduate of Georgia Tech, a licensed fee in the state of Georgia, and a mother of 2 adorable girls and a precious baby boy on the way. So please join me in welcoming Victoria.
All right, thank you, Ashlyn. To thank you all for the opportunity to be here today to speak about our program, and I want to give a quick overview of what GDOT has done so far in the world of V2X technology, and a quick kind of overview of or look back at World Congress. I know it's been a couple months now. It feels like it was either last week or last year. I can't believe it's just been 2 months since we had people here. Oh, Ken, I wanted to ask, am I okay on sound? Okay, all right. Okay, so before we get started too much here, I wanted to kind of get an understanding out of what V2X is. When I talk about V2X, it until recently would have been called connected vehicles. We're sort of shifting nomenclature a little bit. V2X stands for V to anything, V to everything. It can be a vehicle speaking to another vehicle. Yes? Yes. Okay, how's that? All right, good deal. Yeah, I'm not loud spoken, so please keep doing that if I need to be louder. So it could be a vehicle speaking to another vehicle, to a pedestrian application, somewhere to a network. For us at GDOT, we're normally referring to vehicle to infrastructure communication. So most of what I talked about today is going to be a vehicle communicating with a traffic signal. That's where most of our deployments are. So if you'll forgive my pretty rudimentary illustration here. A deployment's going to consist of a roadside unit, that's a radio that's placed at the roadside, or an RSU, usually connected to a traffic signal controller. That RSU needs something to speak to, so we also put an onboard unit onto a vehicle. Those are right now going to be aftermarket radios that we're installing onto vehicles. There's a two-way communication between those 2 radios. That communication happens over a dedicated band, a 5.9 gigahertz band that's regulated by the FCC, and it's dedicated directly or specifically for these ITS communications. Messages that are being transmitted or follow standard message formats. One that you'll see a lot is SAE J2745. There'll be a quiz at the end of all these numbers and letters. So messages are exchanged in a standard format, and they are secure. They can be secured. We can sign our messages at the roadside with through a IEEE, sorry, numbers and letters again, IEEE 1609.2 protocol. We sign all of our messages so that any vehicles receiving those messages know that they're coming from a trusted location, that they're trustworthy messages that are going out. So those are characteristics of the messages that are being sent. What are those messages? Coming from the infrastructure, we're broadcasting things like signal phasing and timing, so SPAT information from the signal, map, which is just roadway geometry information so that a vehicle knows where it is on the roadway and what messages apply to it specifically, which approach you're in, what lane you're in, that sort of thing. And then traveler information messages would be any sort of alerts that we want to broadcast out. So those could be weather alerts, work zone warnings, back of queue warnings, all of that sort of thing. That's information going from the roadside to the vehicles. Then coming back from the vehicles, we can receive information that way too. The most basic information that would be coming back is called a basic safety message, or a BSM. That's going to be the location, or at minimum, the location and heading of a vehicle. It could be additional information such as the airbag status, brake status, windshield wipers, headlights, anything, any information of what the vehicle is doing. We can use that information to make insights or build insights on what's happening on our roadways. So if you see a brake event plus windshield wipers from a lot of different vehicles, you can kind of infer maybe it's raining. Hard braking plus airbag deployment, there's probably an incident that we could go respond to. So that's information coming from the vehicle. There are also some vehicle types that could send signal request messages. So a transit vehicle could request priority at an intersection, or a fire truck could request preemption. Those messages also need to be signed, just like the ones that we broadcast out. They would need some sort of signature coming back. And then, all of this together is the vehicle communicating with the roadside, but that doesn't do much for the driver of the vehicle. So if you want to get messages to a driver, you also need some sort of human-machine interface. It would be an HMI, it would be a tablet, a heads-up display, something in the vehicle that could process the information coming from the roadside and put it up in or display it in a human-readable format. So a 10 message could come through as something that looks like an MUTCD sign in your vehicle. I think that's a lot in one slide, but I wanted to kind of set a baseline understanding before going much further. So all of this together, the goal of getting all of these messages out. Oh, I'm sorry, I left out one thing. The characteristics of these messages that are going, because they're traveling over a dedicated band and they have a standard message format and they have that security, everything that happens in the V2X world is going to be interoperable between different vendors. You're not relying on how does one OBU interpret a message that's coming out from an RSU, and it doesn't have to be the same vendor moving back and forth. So that means, if we have a CODA OBU on a vehicle, it can receive messages, yes, from a CODA RSU, but also from a consignia RSU. And just like it can receive from the same message from different RSUs here in Georgia, if you were to take that vehicle, drive it down to Florida, Virginia, over to Utah, you're going to get the same messages in your vehicle. That's sort of a big benefit of this technology, is that it's interoperable between vendors across state lines. Everything, you're going to get the same messages in your vehicle as you go. So the goal here is to create a seamless communication network between the vehicles, the roadside infrastructure, and traffic management systems to improve overall roadway performance. Deployments are expected to bring significant improvements in both safety and mobility by reducing crashes, improving traffic flow, and just giving drivers more timely and accurate information on road conditions. Okay, no, that's a lot. I'll move forward. So what is Georgia doing in this space? Thank you, Ashlyn, for saying, we've got the largest deployment as far as RSUs go nationwide. We've got over 2,500 radios deployed throughout the state right now. And that number is growing daily. The BBH is out there right now. Yeah, daily. The numbers are increasing. Our deployment started in 2017. We took up the AASHTO SPAT challenge, which urged states to broadcast SPAT information from 20 signals by the year 2020. We jumped on board and selected 54 locations along 2 of our RTOP routes, and then started broadcasting from those 54 locations back in 2017. And since then, it's grown over the years up to this 2,500 number that we've got today. Our goal is to establish a baseline system throughout the state where we know that anywhere you're driving in the state, if you're on a state route, you'll be able to pick up messages from our signals. So we're looking to install RSUs at every every on-system signal statewide by the year 2033. That's going to be a total of 6,500 RSUs. That is the gauntlet we've thrown down and the goal that we're working towards right now. I would also love to continue working with local agencies. I don't want to limit this to state routes. That's just where we're starting. I'd like to keep working with our local agencies. If you're interested in doing a deployment and you want to get into connected vehicles, please reach out to me. We've got some mechanisms and contracts that you can piggyback on, or just work with us to get RSUs in your on the off-system signals as well. Speaking of those local agencies, we're wrapping up right now the end of an initiative that was a partnership with ARC to put out radios in the Atlanta region. I lost what ARC stood for in the ARC area. So all of these counties and cities that you see on the screen here participated in what we call the CV1K program or the RCV program. There's a lot of different acronyms that we go by. But through a local match, we were able to put out RSUs in all of these cities. And you can see the how many are on the screen right now. Henry County, the asterisk is Henry County's got more than 20 RSUs, but there were 20 through the RCV program. So we put out RSUs at all these locations, and these are the applications that are running. The ones that are in italics are still underway. We're still working with some of those cities. I think Johns Creek is very close, right, to not being italicized anymore. So we're working with their fire stations to get OBUs put on their trucks so that they'll be able to request that preemption when they're coming out to the signals. And then you can see the bold ones are the ones that are actively in use right now. Would love to add to this list. As I said, we're sort of wrapping up that first round of this initiative, but we are getting ready to kick off a new contract, and we do have some funding mechanisms in place. If there's a local agency, as I said, that's interested in doing a deployment, if you've got an application in mind, please come talk to me. We'd love to get you on the list and get you programmed in to install more of these radios and get more applications running up and running throughout the state. And it doesn't have to be in the Atlanta area. That's just sort of where we started. Wanted to highlight one local agency in particular, Gwinnett County. As you saw on the previous screen, they used the Regional Connected Vehicles contract to install radios at 385 signals, which someone from Gwinnett, correct me, that's about half, right, of the signals in Gwinnett County. So that's a huge undertaking. Really appreciate the commitment to get this technology out on the streets in Gwinnett County. But installing the radios wasn't enough. They said, well, we want to use them. We want to run applications and get our OBUs installed too. So we worked together to develop the Smart Corridor contract. It was another totally new contract mechanism that was more focused towards OBUs and application development. So through that contract, they were able to install 132 onboard units. That was on all of their transit buses, fire, ambulance, and as well as maintenance vehicles throughout the county. They've got, you can see the applications on the screen that they're running. So TSP and EVPs running throughout the county, as well as a pedestrian presence alert. That one is only happening in Gwinnett County right now. It's if a pedestrian actuates the button to cross at a signal, then the RSU broadcasts out a TIM message alerting a vehicle that there's a pedestrian in the area. And then there's also the REBA rail intersection blocked alert application in Gwinnett County. A few other deployments to sort of highlight, or projects I wanted to highlight while I was here today. The ATC MTD grant. which stands for that, I'm not going to read it out loud, focuses on, it included deployment of CV applications to provide emergency vehicle preemption in this area near the connector in North Avenue, which I think everyone in this room probably knows is a very congested corridor or congested area. The idea here, there's several use cases built into the grant, but the big ones are emergency vehicle preemption for a HERO, which is the the orange route, a HERO being able to make a turnaround to move from southbound to northbound, and it'll flush out the traffic along North Avenue to allow for that. And then also EVP for ambulances that are on their way to Emory Midtown to make a similar flush out as emergency vehicles are going to Emory. This project, it's a 4-year grant. We've just entered year 4, and we're fully operational as of September. The preemption is working in this area. So if a HERO comes through now responding to make that turnaround, they should be getting that preemption call to make that turnaround. A few transit projects, that are underway statewide. Transit's another huge effort, or it's something that we can accomplish through connected vehicle technology. We've got down in Savannah, Chatham Area Transit, or CAT, we've got 3 routes that are outfitted with RSUs and have priority installed on those, or programmed there. So for the buses in Chatham, in Savannah. MARTA also has several BRT projects and ART projects that are either in the pipeline or being constructed right now. So we're staying in step with MARTA on those projects to make sure they've got RSUs installed and working with their signal timing teams to negotiate to handle the Q jump and TSP that's going to be required for those projects. That's just an example of Summerhill, which is under construction right now. And then there's several others in the pipeline there. I've been speaking mostly on connected intersection applications because that's really where we've got most of our deployments. Like I said, we've got 2,500 of those, and they're all broadcasting SPAT because that's something that's available and ready to be broadcast out. But we are also looking at freeway projects. What's shown on the left is the Ray partnership. As from a few years ago, I want to say 2020 or 21, we worked with the Ray, Panasonic, and Kia. We installed RSUs along the interstate, an 18-mile stretch of I-85 down at the state line, and then put OBUs on state vehicles as well as Kia fleet vehicles in that area. And the purpose of that deployment was to prove out freeway-based applications. So like I mentioned earlier, back of queue is one, incident detection, weather detection and alerts, that sort of thing. So those are more TIM message focused and less intersection-based messages. We saw success there, and we thought these were good applications that would be good to broadcast out in other places around the state. So shifting over to something more current, when the broadband P3 projects started being formed a few years ago, I'm sure most folks are aware of those projects, but they're design build projects coming out of our ITS group that'll install install fiber along all of our interstates and several freeways throughout the state. As part of that project, we'll also be installing RSUs at every interchange throughout the state. So that's going to give us that coverage along interstate to expand out our more freeway-based applications. So excited about lots of things coming down the pipe there, both on signals and freeway sides of things. All right, I'm going to shift gears and shift gears. I want to look back at ITS World Congress, which maybe Matt wasn't impressed by, but I thought it was a great conference. Can I get a show of hands? Who was able to attend the conference in some capacity? Oh, that's awesome. Yeah, wasn't that exciting having it here, just down the street? So when we, knowing that this conference was on its way and that we'd have this huge worldwide audience here in our backyard, be able to meet with ITS leaders from around the world, we said, well, this is just happening just a few miles away from our office. What can we do to really highlight some of the deployments that we've done, some of the applications that we've developed, and that sort of thing? And we started thinking, well, we put an RSU at our booth in the vendor hall. What does that look like? What do we gain from that? And then the more we talked about it, we said, well, why do we need to set up a demonstration area if we've got these devices in the field? We already have hundreds of radios throughout the city of Atlanta and even in the area right around World Congress. So why don't we let the ITS community know that these radios are out there, these are the messages, like we've got messages that are being broadcast, and we don't have a huge audience for those messages right now. There's not a lot of folks out there with OBUs on their vehicles, but we know that the vendors that are coming that will be in town, they've got OBUs on their vehicles. So, and they've probably got applications they want to highlight. So we started out saying, well, we'll just provide information about what we've got in the field so folks can come and they can do their own demonstrations, and we can say it's powered by GDOT, and that's great, and all move on with our lives. And it wasn't that simple. It turned into a lot more of coordination with the vendor community. We had 14 different vendors that participated in this, what we ended up calling the Day One Deployment District. The Day One meaning if you have an application that is Day One ready, tested, proven, mature V2X application, you can come and demonstrate or use it, not even demonstrate, just utilize those applications in our area. As I said, 14 vendors. ITS America, we worked with them, and they set up a corner of the demonstration area in the marshalling yard for us, specifically for the DOD, as we eventually started calling it, which sorry, I was really happy that took off, and I don't know if Alan, I don't think he's here. I don't think our friends that didn't go to Georgia Tech realize how happy Justin and I were that we got that name out there. We had 7 different experience stations. Some of them were stationary there at the marshalling yard. Several others, I think there were 4 that were actual ride-along experiences. We even tried to move away from using the word demonstration because we wanted people to know this wasn't a short demo. These were experiences that you could go on there. We've got another slide with just some photos. We had over 1,000 attendees come through the DOD, which we were really excited about because there were 6,000 at the conference overall. So that's a pretty good hit rate on people that were willing to hop on a shuttle and come up and visit us. Almost 350 of those rode in a GDOT vehicle to see the GDOT applications that we were wanting to highlight. And those attendees, they varied from folks at the attendees that had never heard of V2X before and were just interested in what it was, to some local agencies that had heard of it but didn't know what could really be accomplished. We also hosted what we called our VIP ride-throughs with folks from USDOT, ITS America, just to highlight that, or to let them see in the field. Some of them had seen kind of closed course demonstrations of V2X, but maybe not seen it in live traffic. And I should have said at the beginning, sort of our goals here, we wanted to let people experience the technology and see the fun applications on the tablet and that sort of thing. It's always exciting. But we also wanted to show our USDOT and automakers that there's an appetite for this technology out there, and that there is potential for additional safety and mobility applications that are really going to save lives and improve traffic. And we need to do whatever it takes to take that next step forward to try to increase the penetration of this technology in our with the traveling public, not just have these onboard units installed on buses and fire. Those are great uses, but we really want them more in passenger vehicles. So we're just trying to put it out there that the technology exists, it's being used, there is an appetite for it. So sorry, got a little on a soapbox there about that. But we've got good feedback. I think we may have made our point, at least with USDOT. We got a lot of good feedback from the guys that we had down here from them. So this, in the lower right, this is Brian Cronin from USDOT holding one of our tablets in one of our Explorers. And you can see the application that we use, our tablet-based application that's really just used for demonstration purposes. And I'll show a little bit more of that on the next slides. But yeah, so was anyone here able to, were you one of the 343 people that rode in the GDOT demonstration? Yeah, I know Mohammed was. All right, yeah, so if you didn't make it, this was the route around the World Congress Center area where we hosted those ride-alongs, and then all of the applications and messages that were being broadcast around that route. I have to walk through some of those right now. As I said, the app that you see on the screen, that's really something we just use in our vehicle for demonstration purposes. It's not something you can get from the App Store, but I think it does show some capabilities of what it could look like if there were more apps out there that could take information from the roadside and get it into the vehicle. And so this is just one way of showing some of this information. There are other vendors out there that do have, native apps that you can utilize. But this, so, all right, sorry, back up. All right. As you were in the vehicle traveling around, you'd be able to see on the screen, as you approached any of the 16 signals around this route, the SPAT information that was coming in, it would show up as an indication of what your traffic signal saw, so a green indication here, as well as a countdown to the next phase, and then a speed advisory for how fast you would need to go to maintain, the speed you would need to maintain to get through the next light on green. And that's something that's being broadcast at every one of our connected signals around the state. A few other applications that were around this route. I didn't mention, we've recently installed LiDAR along Northside Drive over by the stadium over here. And we're looking at additional LiDAR deployments around Metro Atlanta and other places in the state too. But this was our first deployment of LiDAR. That's basically radar, but with lasers. It's like the easiest way to describe LiDAR. It can pick up anything that's at the intersection and classify, so vehicles, pedestrians, bicycles, anything it can detect at the intersection. And then the LiDAR units that we had can package together what's called a censored data sharing message. That's one more type of message that I didn't mention earlier that can be broadcast through an RSU. So it takes a message of, here are all the pedestrians in an intersection, and broadcast it out through the RSU. And then when a vehicle with an OBU approached an intersection, it would know if there was a pedestrian within a certain cone of vision. And if there was, we'd put up an alert saying, pedestrian in the area. If you're close enough to the screen, you can see the distances in meters. We changed it to feet as we got a little closer to our demonstrations. Some other messages that were being broadcast out are traveler information messages. I probably won't go into every single one of these, but that in our application shows up on the right side of the screen, and it's just advisory or just information about what's happening in the area. So we had speed limit, a weather advisory that I think it said gusty winds. We put a low vertical clearance warning on the pedestrian bridge just to show the capability there. Work zones and lane closures. So as you navigated around, you got all these messages coming into the vehicle. Finally, the last application that we highlighted during this ride-along, this was a brand new application for us, and it's actually a V2V application, so vehicle to vehicle. We had our Hero unit, which had an onboard unit installed. I wish I had a video of it. As it was responding to an incident, which we simulated on this orange part of the map here, as they were responding to an incident, once their light bars on and they went under a certain speed threshold, I think 15 miles an hour, the OBU would start broadcasting out a message that was dynamically creating a map message there in front of and behind the vehicle for other vehicles to pick up, and it would show a flashing yellow indication if the vehicle was moving slowly, and then it would switch to a flashing red if the Hero was stopped and responding to an incident. And that's something that was brand new the week of World Congress that we were wanted to demonstrate down here. So we would love to expand that out and get it on our hero vehicles as they're out on the interstate responding to incidents. But we just wanted to highlight it here as an example of another application. Wanted to thank it was a huge undertaking trying to get all of that ready. I know it looked like just a little circle on the screen, but a lot of work went into making those experiences happen, the DOT itself happen. Wanted to thank our consultant and contractor partners for making it a success. So these people made sure our radios were up and working on the roadside, our the network was stable, we had good communication between the signals, our actual applications were working, signal timing, just any number of things leading up to and during the week of the conference. So I want to really thank these guys. And then not on the screen, endless numbers of people from GDOT helped make it a success too. So IT, making sure we had a stable network again. Our legal team, we had to sign I had to get waivers signed to put people in vehicles and sign to have a booth on the floor, and there were all sorts of signatures popping up that none of us saw coming, and legal worked really fast with us to make sure all of that happened. And then of course, from the TNC, we had a team of 24 people who were attending the conference, and all of you may not have known that you were signing up to help me quite as much as you were that week, but wanted to thank, I see a lot of y'all here. Austin was hauling trailers back and forth from OEM, and we had people driving vehicles during the ride-alongs and trying to corral attendees and hosting, working at our booth in the exhibit hall, and it's just a lot of work went into it, and there were a lot of people involved. I really wanted to thank y'all for that while I had a couple minutes here. All right, so that was World Congress. What's ahead, what we're up to next? These are our big initiatives, or initiatives that we'll keep working on for the next foreseeable future. Continue those RSU deployments. We're going to hit that 6,500 number by the year 2033. That's the goal. We want to expand out on our existing applications, so continue finding opportunities for transit signal priority, emergency vehicle preemption, expand out those hero applications like that new V2V application that we were talking about a minute ago. Also, want to continue working towards some more vulnerable road user applications. That LiDAR SDSM is very new on a nationwide level. I mean, that's not just new in Georgia. That's like a very brand new message type that's being broadcast. And then, of course, work zone applications. Work zones are on everybody's mind right now. So working on how CV or how V2X fits into that world. And then I've got a few QR codes here. We recently published our website. I'm not sure if I've gotten the word out about our website very much, but we do have a website that has a little more detail about everything I've gone into today, and a lot more on the history of V2X and how we got to where we are right now. And then on the right is a link to our roadmap, which is our 10-year plan of what everything the GDOT wants to accomplish over the next 10 years through V2X. And I've also put up an email address for the program, but I'm the only person on that inbox. So if you've got my email address, you can go straight to me too. It's fine. Yeah, and I think that's my time. So I'm happy to answer questions if there are any. I think Danny's got a microphone. Okay.
So on the screen, I noticed that in Gwinnett, they have an application with rail. Can you explain a little bit about how that looks or how that's working in the field?
So it was a question about Gwinnett's REBA rail intersection blocked alerts. And I'm actually not very familiar with what that looks like, and I know I should be. I don't know if I could toss it to someone from Gwinnett if there's someone here that might have more information, or is that something we can? Okay, all right. I'm sorry, some mystery person from Gwinnett. I'm sorry again. Phone a friend.
So it works similar to the pedestrian alert, where if the traffic signal near a railroad gets a preempt, it'll broadcast that there's a railroad or a train coming on in the area on the road.
So it's based on the preemption at the signal itself, not
Correct.
a, not a detection of a train. It's
detection
not
of
something
the train.
separate.
Right,
Okay.
right. The preempt at the signal, that triggers it.
All right.
Yep.
Thank you. Learning together here. I'm sorry. Thank you. All right.
When you're sending out messages, are they blasting out in a radius, or are they identifying people that would be impacted by it, like approaching vehicles?
It's broadcasting out everywhere. Broadcasting in a, sorry, the question was, are the messages being broadcast in a radius or directly in a, in a specific direction, right? So the messages are broadcast out everywhere, but the vehicle is, a vehicle, the messages also has a map attached to it, so a vehicle would need to be inside of that, that mapped area before it gets an applicable message. Right?
Okay, so I know that there are V2X applications out near the ports in Savannah for freight. With the application with freight, is there something already established in the trucks for the OBU? Like, can it tie into an existing system, or do they need to put in a specialized OBU to receive those messages?
So questions about freight applications, which I don't think I even mentioned one bit here. Sorry about that. Just was cutting things for time. And whether or not they can utilize existing radios on a truck. Any freight partnership that we've had, we've needed to go and install a radio. So they need to be a V2X radio. Those are more, the radios that are on the truck now are going to be specific for a specific purpose, or sorry, yeah, targeted for a specific purpose. So we're needing to install radios on those. And the freight applications that we're running right now, it's freight signal priority, which I didn't touch on earlier, but I'll take a second if I can. It operates similar to transit signal priority. The difference would be transit signal priority is going to be based on the, based on their schedule. So if they're behind by 5 or 10 minutes, then they'll put in a request. Freight's going to always put in that request because it's less about it's less about making sure they're on schedule and more about reducing the number of stops they experience on a corridor. And we do have one pilot right now, and we're looking for more opportunities for additional partners for freight signal priority. Other questions?
I'm curious, and this might be like a little further out in the future, but have there been discussions yet about what the heads-up display might show? Because I know there's probably a balance between showing too much information where it's taking your eyes off the road, or what is the priority information to show. Has that been a discussion yet?
Those are definitely discussions that are happening. I feel that it's our job to put out the messages. It's more on the auto manufacturers and the app developers and that sort of thing. No one wants me, the state, saying what needs to be in their vehicle. So I think that's much more on the automakers and the app developers to say what should be on their applications and what level of information. I know for one, if I could use CompSignia as an example, I know that in their app that they've got, it's the user can determine which messages they see. And we saw an example, was that in Peachtree Corners where you had like hundreds of messages showing up, or the ability for it? And obviously that's not something that you want, right? And you use that as an example. You said obviously no driver would want all of these. So there's, I think, work to be done to establish those like levels of how much information is coming into the vehicle. Yeah.
For integrating it, I guess in the cars and stuff, is it something more that would it be easier to try and do it so it's more integratable with like Android Auto and Apple CarPlay, since that's more universal versus like the auto manufacturers?
So a question about integrating this information. So are you suggesting, or asking about sending broadcast or sending directly to Apple and Google instead. That's a conversation that comes up a lot. I think the latency isn't quite there because a lot of the applications that and there may be a space where maybe our TIM messages, that sort of information that could be delayed by a few seconds or a few minutes, a lane closure up ahead, the latency there isn't critical. That could be information I think that could be shared with other network providers. But some of the, especially intersection-based applications, are going to require a latency, like a sub 40 millisecond latency, and that needs to happen over a faster, a more direct connection. So that's the purpose for trying to or wanting to rely on this this sort of technology. Yeah.
Victoria, in regards to the LiDAR and pedestrian safety improvements, since Atlanta's hosting the World Cup next year and stuff, are they engaged or is GDOT engaged in deploying more of those for that event?
Yes, definitely. That was the justification for putting out that LiDAR along Northside Drive. It was the beginning of trying to outfit that event space a little bit more, not just for World Cup, but for other events. There are major events happening. I mean, Juan could tell me how many a year probably are happening in that area. But there's so many pedestrians in that area. That's why it was such a good test base for that LiDAR deployment. And there's other ones. Right. Yeah. There's already other ones underway right now. Nancy.
Hey, Victoria. Curious, the buy-in from the auto manufacturers, has there been, are they starting to deploy those onboard units? Is that going to be standard equipment someday, or what's the time frame?
That's the goal. Asking about automakers and the time frame for getting onboard units on the vehicle. On the vehicle, if it's done at the assembly line, we're talking about just chips on the vehicle, right? Not a whole separate radio that's being installed. There is hesitation from auto manufacturers. I've heard, you hear different things from different people, but one thing that I've heard is they're waiting on legislation. They want NHTSA to say it's required. No one wanted to be the first one to put a seatbelt in the vehicle. So they're aware of it. There are people in the OEM agency or companies that are pushing for it, but there's just not that top-down pressure to start putting these radios in the vehicles. In Europe, they've got them, and if you talk to someone from Europe, they make it sound like every vehicle has one. I don't know if that's accurate, if it's quite that many. But they've gotten there in Europe with the DSRC chips. They're putting them on the vehicles, and they're definitely capable of doing it here. I think they need either that legislation to say you've got to put it through or start installing, or someone needs to take the first step and be the first one, because it seems like no one wants to be the first manufacturer to do it, but they're all ready to jump on board, I think, once some momentum starts happening there.
I just remember years and years ago, Lexus, and they were doing presentations and various things, and it just, I've been waiting for them.
Right, right. Yeah, so in the meantime, we're relying on more fleet-based applications. So we're trying to install OBUs on fleet vehicles, so our buses, fire, ambulances, hero trucks, those fleet vehicles, and to try to get whatever applications we can right now out there and make sure we've got as much penetration as we can and show that there is a benefit. That way there's a benefit and there's also sort of a baseline across the state. We want folks to know, or we want the manufacturers to know, they don't have to just drive in Atlanta, Georgia. They can drive. It can be vehicles anywhere in the state of Georgia. And then we're working with other states to say, oh, and in North Carolina and in Utah and all these other states, that there is an appetite, but it's this whole chicken and egg thing. Infrastructure owner operators are waiting for the OEMs to start putting radios out there so that there's someone receiving the messages, but the OEMs on the automaker side are waiting for messages to start being broadcast. So it's a little bit of chicken and egg there. Yeah.
Hi, Victoria.
Yes.
I have a question about that would arise when auto manufacturers start installing that. they have access to the data, I believe, if they install the onboard units. And would there be like an agreement on what they can use the data to do? I'm just wondering how that works, because they probably have access to the data if they install the onboard units.
It's a great question and really getting above my head as far as legal issues go and that sort of thing. I will say though, any new vehicle that's going out right now, is the manufacturers will say they're a connected vehicle if they've got any sort of your OnStar system or any other, excuse me, the ADAS, and I'm losing what ADAS stands for, but there's data out there, and I'm assuming there are those sorts of agreements or those sorts of boundaries in place on what they can get back and what's anonymized, but I think I'm getting a little out over my skis as far as legal things go there, so I'm sorry, I don't know if I addressed that at all. Yeah. Okay, yeah.
So I can share a little bit of information to that question. Yeah, so basically the last two questions. The automobile manufacturers already have designs for the chipsets and the software in the books on the shelf, and they're just waiting to take it down and install it in the next set of vehicles that are going out. From a information sharing perspective, there's two key pieces. One, when you buy a new vehicle now, even though it doesn't have a C-V2X chip in it, it's probably got 4G, 5G, and you already have to sign on one of those 3,700 pages when you buy the car that all that data goes straight to the automobile manufacturer. So there's a little bit of proprietary play here from manufacturer to manufacturer of how are we going to use this data and how are we going to monetize it. So the CV piece is going to kind of dilute that by allowing all that data to be used across. So that's the first piece. The second piece is with the CV protocol, you're allowed to anonymize the identification factor on the vehicle or the OBU. So in 25 seconds, your code is going to change. And then in another hour, your code is going to be different again. So the only people that know who you are and where you are is, let's just say in the future you use it to pay tolls or you use it for some other type of identification. But everything broadcast over the air is randomly changed from an identification perspective. So if you drive your car home every night and it's parked in the driveway, nobody can figure that out because the new ID is parked in your driveway every night.
Thanks, Gary. Can you just follow me around all the time? Anytime I talk to people, that would be great. Yeah. Okay. Any other questions? Comments? All right. Guess we're okay then. I'll hand it back to Matt. Is Matt around? Okay, there he is. Okay. All right. And thanks everybody. Sorry, thank you for having me here. Really appreciate it.
Easier to do that.
All right.
So is this on? This concludes our monthly meeting. You are welcome to hang out and bother Brian and team. I'm sure they would love to have you. Otherwise, you're free to go. See you in November for our awards banquet. Register now. It should be open. It's open. It's open. Register now. Tomorrow, just joking. Register tomorrow. Not today. Register tomorrow. Make sure you're one of the 100 people that are there because the seats will go and the food is delicious. That's it. Goodbye.
Good. All right. We can see a whole bunch of vehicles on the screen as I'm driving out here. And this is now a connected vehicle application, which is connected to all of the infrastructure within the whole city of Alpharetta. You can see all the connected vehicle apps, as well as pedestrians and cyclists that are all shown up on here. So as I'm driving up towards the traffic signal, I'm going to pop up and show us some phasing and timing. So at the bottom there, you can see the signal phasing and timing. As I drove over the loop, now I actually connected in to the traffic signal, and we can now see exactly how much time we're going to have to wait. This is coming directly from the applied information RSU processor. This is getting sent out over cellular communication directly to the mobile phone. If we have an OBU in the vehicle, we can connect the app directly to the OBU as well. For this demonstration, I'm showing what we call the diagnostic mode, which allows us to see second by second communication. When we have the people from the general public jumping in, what we do is we don't show them 55, 54, we just show 50 plus seconds, 40 plus seconds. Now, what the vehicle will do is it will also connect, and as soon as the traffic signal counts down about 3 to 4 seconds before it's going to go green on our left turn phase, it'll actually say, get ready for green. Get ready for green. So you see that get ready for green, and you're going to see our signal's going to change to green. I stand to be corrected. You have a look up there, they did an extension on the on that phase, so they extended it again. Now, this is something that the traffic controller shouldn't actually be doing in terms of counting down and then counting back up, but that's a controller manufacturer side of things, a bug on their side. As we drive along, we're going to see different traffic signals ahead, and as we get closer to it, it'll pop up at the bottom with the actual signal status information. So you can see we're going to have to wait for another 20 odd seconds, and then it'll pop up and actually do the same get ready for green message to us when the signal's going to change. Now, there was a question that came up, which was, what should you be showing to the user? We've done a lot of studies with the University of Florida and various others. All of our apps, 97% of the people run this app in the background. So it's all audible alerts first. It's a critical thing because you want to basically provide that information directly to the people as an audible alert. And that allows you to basically get all of that information from the drivers on that side. Now, when you're using the public app and it's telling us 41 seconds of green, we don't tell you how much time is left on the green phase on the public facing app, just because we want to just basically show, we don't want people racing a traffic signal. And as I said before, 93% of the people are running the app in the background, and then they have Google Maps or Waze on top of this, and they're just getting the audible alerts. Around the corner here, what we've got is we've got a virtual school zone because there's not a school zone nearby. So on this roadway, you'll see that little school beacon icon over there. We've just set up a school beacon on this roadway. So as we drive more than 5 miles above the speed limit, we're going to get an alert that we're speeding in a school zone. So I'm just waiting for the traffic over here to turn. So I'm going to drive at 30 miles an hour to then get a speeding in school zone alert, or more than
Speeding in school zone.
if I slow down, the alert will clear, and if I speed up above the 30 miles an hour.
Speeding in school zone.
So you can hear how that, and you can see it's already got us down, and it tells us the information that it's a school zone and it's 25 miles an hour. We'll see the signal status here. This signal that's going to be changing
Get ready for green.
in a couple of seconds. Now, what I'm also going to do, I'm going to stick the car into autonomous driving here. I'm going to navigate back to it. So now what it's going to do is going to drive us back without me touching anything. So this is the Tesla now driving and stopping at a stop sign, looking for the cars on the left. It sees the next car on the left. It won't pull out because it's not thick. And this technology has improved a huge amount. So now the car's driving itself back to the office, getting into the correct lanes, putting the correct turn indicators on as well. So you can see now it's turning to the right, and at the same time we connected to the travel safety information as well. Now the car's going to pull through here because it's a yield sign, and it's going to look and see if there's a gap in traffic that we can pull out. And it's using all of the 8 cameras around the vehicle to make that decision. And you can't feel this, but it is really, really smooth. Does a great job of running through that. Now, if I had driven really fast towards the traffic signal, we also do red light running alarms, so it'll pop up and
Get
say,
ready for green.
red lights ahead if we're not going to stop in time. So
Get ready for green.
all of those kinds of things pop up as an alert for the driver. And this is still the car driving. I'm not touching the steering wheel at the moment. And you can see the signal ahead is red. And as we get up into the zone, it's now popping up and telling us exactly how much time we have to wait in that zone. So what we're going to do is we're going to pull into the office next. And we've got some of the other alerts. We're talking about hero vehicles and things like that. We're going to show a school bus alert and a work zone alert. So we have about 30 different applications that pop up in this app. And obviously 30 different applications. There's a lot to show off. We'll see here's another vehicle that is driving people through, coming up on the other side of the road. That's one of the other Teslas. So all of the vehicles are also connected to the ecosystem. So there's something called the Travel Safety Data Exchange.
Get ready for green.
All of these vehicles are all connected into the Travel Safety Data Exchange. And we've also opened this up. So in Florida, they've got a 511 app. All of the Florida 511 apps are also connected to the data exchange. So if you want to take it out of autonomous, just put your foot on the brake, or you put your foot, or you grab the steering wheel, and that'll take you out of being an autonomous drive. So I'm just going to drive down here. We can see there's a number of cars parked over here ahead of us that are driving people through the travel safety system. And you can see all of the employees here that are also all connected, and there's even pedestrians on the map that'll show us the pedestrians on the map. Now there's a DHL van in front of us that is trying to do a delivery. So we're just going to drive through here to where the school zone and school bus alert is.
School bus stopped ahead.
And you can see we've just put a school bus just on this corner over here to have it stopped, and it's actually in the lab.
School bus stopped ahead.
And it's showing that it's actually got its stop arm open. And that's that alert for school buses.
School bus stopped ahead.
Now we're going to, and normally there'd be a physical school bus over there, obviously we don't have a school bus parked there today, but during the ITS World Congress, we had a school bus stop there.
School bus stopped ahead.
Now, what I'm going to do is go through to an area that we created a work zone. So when you have a vehicle that has a OBU in it, and it has its hazards lights on, it'll pop up with a work zone ahead alert. And all of this can work over both CV2X direct messages as well as CV2X network. And that's the beauty. You can see here it's in the speed.
Speeding in work zone.
And as I slow down below
Speeding in work
10
zone.
miles an hour, which is what we set up as that alert, the alert won't pop up again. And the great thing with this is obviously you've got both cellular communication as well as CV2X direct radios broadcasting the message at the same time. Our latency for network messages is between 100 milliseconds and 300 milliseconds. So all of these alerts you just saw today were all over the network side. It's more than fast enough to do all of the connected vehicle messages. Vehicle to vehicle or automatic braking alerts, that would be one that I would probably not want to do. But everything with infrastructure, you can do it. Plus, you can also integrate and share information with things like Waze and those kind of areas. So if anyone wants to jump into the vehicle and experience this for yourselves, please do. Please jump in the vehicle. Come see what autonomous driving is like in the Tesla, as well as all of these connected vehicle applications that you can see on this app, which is live on the roads today, which is fantastic. So I'm going to pull off and stop over here and allow people to jump into the vehicle. Now, we're not sure if all of that works, but we'll find out. Back to the future. It kind of feels like I tell the kids I can fly there.